Hello. Hey, first of all, thank you all for coming. My name is not Sarah Fender. My name is Ram. I'm one of the co-organizers with John Lambert for this workshop. So before we get started, I'm going to ask everybody who's seated on this nice corner row to defragment themselves like windows and just move to the corners. So that way, if there's anybody who is coming in later, they can easily find their seats. If you're sitting in the corner row, I know it's annoying, trust me. Or you have another opportunity, is probably come a little forward so that anybody who's coming in will easily be able to find a seat. Okay, sorry about that. So first of all, as people are settling in, I want to give you a little bit more context as to why we started this workshop. Turns out that graphs for security is super hot. It goes all the way back to 2009, and you're going to see a rich history of it as well. But when John and I'm part of the Cloud and AI Security Data Science Group, and John, as you all know, runs the Microsoft Threat Intelligence Center. Turns out that both from a security standpoint and from a machine learning standpoint, graphs are extremely pliable tools for analytics. And today you're going to see a very different sort of graphs, and we're going to explore what it means to do graph-based analysis from a database perspective, from a tool perspective, from machine learning perspective. So we're trying to give you a different taste. It's going to be a little bit more of a tasting menu as opposed to one single entree. So hopefully, you're already considering yourself for that. And before we get started, how many of you would consider yourself, actually, how many of you are from Microsoft? Oh, that's actually a lot more than I thought. How many of you consider yourself okay, security engineers, everybody. How many of you consider yourself to be working primarily in data science? Okay. How many of you, I see David's hand is like this. Yeah, I was I'm not sure. How many of you consider yourself more as security analysts? Okay, that's actually a fair bit of group. How many of you would say you know what, hell to all of you, I'm an engineer. I build a platform. I build the system behind it. Okay, so as you can see with this diverse group, the tasting menu approach really does work. There's going to be something for everybody, and I'm sure some of you are going to learn something new, and for some of you it's going to be reinforcement of what you've already seen. Before I start, I want to thank all the volunteers who are kind of putting this show up. Faraz, Walner, Swarupa, Sylvie, and the entire BlueHat crew. It's really easy for us to bring the warm bodies, but without the infrastructure that BlueHat kind of volunteers, it's super hard. I also want to thank the speakers. I know that John Hawes has traveled all the way from the UK for this, and the people have traveled from different parts of the world to come and kind of entertain you today. So with that, I'm going to get started. It's my pleasure to kind of have the keynote from Sarah Fender. Sarah Fender is the GPM for the Cloud and AI Security Group. Prior to that, she led the security initiatives for Microsoft Azure, including Azure Security Center. She actually joined Microsoft in 2012 through the Phone Factor acquisition, where she kind of led a variety of different tools, and she was in fact the vice president for product management. She's got extensive experience in security and compliance and has been in the industry for 15 years. But I always go to her and ask, hey Sarah, what's the best place for me to get good pies? So thank you, Sarah, for joining us today.
Thank you. I'm no expert on pies. I just want to get that out there. But my husband is a chef, which is why Ram and I often talk food. So I just want to say thank you for having me today. I really think this is a very interesting topic, and I appreciate the opportunity to kind of share with you a little bit of my perspective, and to also hear from you guys about what you're doing with the graphs, I should say. We at Microsoft have really been thinking about the application of graphs for security for quite some time now. And that really kicked off in the 2009 era when a trio of Microsoft researchers published a document, an approach, let's say, to combating lateral movement. It was called heat ray. Was the approach. And it really focused on this idea of combating snowball identity attacks. I guess, in the term we can all kind of get an understanding of what that is. Someone's gained a foothold through an identity, is that to move laterally. And lateral movement, everyone sort of understands that today. It's very common, everyday sort of understanding that we have as security analysts and researchers. But back then, it was a relatively new approach. So heat ray really focused on using graphs to sort of map out the relationships between users and identities and machines and security groups with the goal of identifying edges that could be cut to stop that snowball effect from happening. So looking for even minuscule edges in those graphs that could be used to stop that snowball effect. And then if we fast forward a bit to 2015, John Lambert published a pretty interesting blog post that really highlighted this important distinction between the way that defenders are thinking and the way that attackers are thinking. And that really highlighted the fact that defenders are working on lists. They have lists of assets, they have lists of machines and lists of users, and but attackers are really thinking more about what are the connections between those things. And that's important for them because they need, once they gain a little foothold within the organization, they need to be able to move out in order to be able to execute their objectives. And so really just getting defenders to pivot and begin to think about less linear lists of things and more about the connections between these things. And in 2017, Satya introduced this concept of the intelligence security graph at Microsoft Ignite. And this really represents this concept, this approach, that the insights that we have gained from the trillions of signals that we analyze here at Microsoft provides really valuable visibility into connections between users, devices, infrastructure, and more. So really highlighting conceptually the importance of graphs as we try to tackle these very, very challenging security issues today. So why all of this buzz about graphs? Why are graphs important? Why are we all here? Maybe a diversity of reasons, but a couple of things I wanted to highlight. First is that we all know, it goes without saying, that AI is going to be a force multiplier for defenders. And what is the fuel behind AI? It's data. And we need more data and more diversity of data to really make those machine learning models sing. And with that comes some challenges, though. So we've got just huge volumes of data that we need to sort of make sense of, and we need more diversity of data, meaning we need data from across the stack. We need data about infrastructure and users and devices and network activity. We need all of these different kinds of signal types. But making sense of all of that can be quite challenging, and that's really where graphs can come in. So they can make that large volume of diverse data more usable for AI. They provide structure, and then also very, very importantly is context. So what makes a graph a graph? I think we're going to hear lots of different interpretations, lots of different perspectives on this topic today. We can ask ourselves, is a graph database? Do you have to have an actual graph database in order to have a graph? Do you need to have a unified entity model with nodes and edges? Is that what a graph is? Is it the pretty charts and graphs where we can see on the screen, bubbles and lines connecting the different bubbles? Is it those kinds of visualizations? I would argue that the most important thing, the really underlying fundamental thing that defines a graph is relationships. And so as we think and hear from different topics or presenters throughout the day about different approaches they're taking to graphical analysis, I think the one thread that I would expect to see sort of common across those is this concept of relationships. So as we apply a very broad definition of graphs for security, I wanted to talk for just a moment about how the Microsoft graph fits in. How many of you are familiar with the Microsoft graph? Good, a good number. So my team owns the Microsoft Graph Security API, which we'll talk about here in just a minute. And I often get asked the question, is the Microsoft Graph a real graph? Is it a real graph? And I would argue that in many ways it does represent those relationships that make fundamentally a graph a graph. So for those of you who aren't familiar, the Microsoft Graph is sort of a single endpoint for connecting to data across Microsoft 365 in particular, and now even Azure and some third-party systems as well. So it provides one integrated way to access that data. So one endpoint that you access with one authentication key. There's one SDK. So sort of bringing together access to these systems and data through a single graph endpoint, graph.microsoft.com. What we're doing from a security perspective, set up an entity in the graph specific for security workloads. And it operates in a little bit of a unique way versus other entities that are in the graph. So it is a unified REST API. It does provide a uniform for security entities. But what's a bit different about it is that it acts as a federated broker. So in many cases, when you ask the graph for information about a user, for example, it's getting that information likely from Azure Active Directory, or about a file, it's getting that information from, let's say, SharePoint. But in the world of security, as we know, organizations have different security controls, many from Microsoft, but many from vendors other than Microsoft. And so they've got all of these systems generating data and alerts and security recommendations. And so being able to operate on top of all of that data can be quite complex. They have different APIs. Even inside Microsoft, each of our security products and services has their own set of APIs that they expose, virtually all of those in an independent schema. And so just making sense of all of these things in the world of security can be quite complex. So the security API works a little bit differently in that it takes a request from an application and it federates that out to all of the security providers inside of Microsoft and some third parties as well, and it returns back an aggregated list of results in that common schema. And we'll take a look in a moment at some examples of how that's useful. So it is not a graph database. It is not a big data store. It's not a data lake. It's not a dashboard. There's no user experience. I'm going to show you a demo in a moment, but that's really just a sample app that we provide to kind of give some ideas of how you can, what kinds of insights you can get from the graph. And it's not a SIEM. We have a SIEM, that's Azure Sentinel. The graph is not that. So let's just take a quick look, do just a super short demo to give you a quick idea of some of the graph-like insights that you can get from the security API. So as I said earlier, the Graph Security API is an API. It does not have a user experience. It's not a finished product. We don't sell it. But we do provide a sample application, which is what we're looking at here, which just makes it easier for developers to kind of get started using it. And you can see in the graph we've got some sort of dashboard-like functions. All of these are ultimately operating on top of simple queries to the Graph Security API. But you can see how you can take those queries and really put those into charts and graphs and tables where you can easily derive insights out of that data. So what I want to show is if we click in on, let's say we want to look at alerts for a particular provider, in this case Azure Security Center. You can see the query that's being operated to return these results to us, and the ability to easily pivot based on different aspects of that alert. So we could, for example, look for only Security Center alerts that are high severity or based on status. And again, we can look across multiple alerts here. I've just drilled down into Azure Security Center as an example. If I had removed that filter, I would see all of the high severity or all of the alerts firing across my environment. I just want to click in on one of these. So here we're looking at network communication with the malicious IP address. And again, all of this data derived in a common schema from the Graph Security API. And we can see all of the alert details here. Who did it come from? Who's the provider? We can see information about the network connection. And I mentioned earlier the ability to get context. So what we're looking at here is some additional context that was pulled not from the security API itself, but from other entities in the graph. So here we can see information about the particular user related to this attack. Patty, we can see her role within the organization, her contact information, where she physically sits in case we needed to, have a contact with her, reach out to her. We can also see the device related to this. Again, this information is being pulled from other parts of the Microsoft graph, not necessarily the security API, but provides super useful context as we try to investigate this alert. But what I wanted to show that I think is the really graph-like component of this is that because we've got this common schema, we can easily pivot from different entities inside the graph. So here we can see all of the alerts that are related to this particular user across all of our different security providers. Right, so we see that we've got some activity detected by Security Center, but also the Cloud Application Security Solution. We can go and find out, are there any other alerts that are firing for this particular host, this machine? Again, we see a set of results from a variety of different security providers. We can pivot to see any other, this particular attack was related to malware. We could see any other alerts that were firing that were also related to that particular malware. So we really have the ability to very, very quickly and easily, through just a standard schema and a set of queries, to pivot between different entities that are related to this alert to gain additional insights. So I know for most of you that are doing really more sophisticated graphical analysis, this may seem like a very simple model, but I think you can see how even simple application of graph-like approaches can be useful in the context of investigation. You can use the Graph Security API to pull that data in to another data store to run other kinds of more sophisticated analytics on top of it if you wanted to. You do still get the benefit of that underlying schema, which is common across, which makes it much easier, as we know, to run analytics on top of that data. All right. Back to our slides here. So I wanted to spend just a few minutes talking about what's next. And it would be great to hear, we might have a few minutes at the end here to have a bit of a quick discussion around it. But it feels like in terms of what's next for graphs, there's quite a bit of investment going on in that detect pillar, kind of the middle part of the security lifecycle. So using graphical analysis to try to detect threats, maybe on the investigation side to sort of understand what is the scope of an attack, for example. So lots of efforts that's happening in the detect sort of pillar. And I expect that more of that will continue over time. And what we'll see, again, is just more data sources and more diversity of data sort of being leveraged for that detection, for those detection capabilities. But I also think there's some interesting opportunities for us to move out from detection into protection and response. We're hearing a lot in the security space about automation being driven by the need to act more quickly in the face of threats, and also to be able to sort of scale out the very limited security resources that most of our customers have to address and investigate and react to these various threats. And so if we think about automation and what it's going to take to get that done, sort of understanding the relationships between things and where to automate, assessing the scope and being able to act on that are some things that maybe graphs might be able to help us with. To understand, so what are the connected things, maybe with similar configurations, or similar users have touched those things. So really thinking about how we can understand those graphs and leverage them to automate response. We're doing a lot of this in Azure Sentinel, for example, which is a product I work on as well, where we can trigger these series of automated playbooks. And it certainly would be helpful to that process to be able to understand these kind of graphical relationships. And then also I think there's some interesting stuff that can happen in the protect space. So as we think about assessing the security configuration of our assets, and being able to take more effective action to defend or prevent attacks from being successful in the first place. We at Microsoft have some unique insights through Secure Score. I think there's some interesting opportunities that may exist there to sort of map out and understand, where we see commonality across our customers, where we can maybe establish some relationships there that might help us to more effectively recommend or apply security protections for our customers. So it's just one example, but I definitely think there's additional opportunity to apply graphs on the protect side of things as well. We've been thinking in my team a little bit about how we might be able to leverage them for threat intelligence. And so, being able, there's threat intelligence is in many ways not super sophisticated today, in that we're collecting all kinds of information about bad actors and tactics and techniques, and we can apply those to try to detect and prevent attacks from those. But there's a huge volume of threat intelligence that exists out there today, and many of our customers are really struggling with how to make sense of that and how to effectively apply that within their organizations. So for example, their firewall can only take 5,000 indicators, or their endpoint protection solution can only take so many indicators. So which indicators do they give them? And so we're doing a little bit of experimenting to see if there's something we can do to understand what indicators are likely to target a particular customer based on their configuration. So can we sort of map out their environment and relate that to other customers that are running similar kinds of environments? If customer B sees an attack from a particular indicator, can we suggest to customer A that maybe that's something that they also want to promote to their firewall or their endpoint protection solution for blocking on that particular threat? So early days still, but really thinking about how we can use these graphs outside of just the kind of can we use them to detect threats. And I think there are lots of different interesting opportunities out there. We're thinking of some. I'm sure you guys have lots of ideas there as well. So as we begin to explore these new opportunities to apply graphical analysis, I just wanted to encourage us to continue the journey together. We know that there's an amazing amount of work that's happening not only within Microsoft, but out there in the industry from others who are trying to solve these really challenging security challenges through the use of graphs. And so just pleased to have you here today to continue those discussions, and look forward to continuing to work with you as we continue this journey going forward. So I have, Ram, I think I've got another 5 minutes-ish, so I'm happy to take any questions. I guess a question that I have for you guys just as we begin the day and put on our kind of innovation hats, what are you guys thinking about in terms of new applications and uses for graph? Does anyone want to share an area where they think graphs are interesting? Yes?
Actually, it's kind of the same, but it's a question more for you, because I don't know the answer, but is there a plan or is there a planner? Does it work? Oh, it's on, okay. My question is pretty simple. Is there a plan to make Windows Update Agent metadata a provider on patch levels of AAD joined devices?
I do not know the answer to that, but does anyone else in the room from the Windows team have any insights on that? Let's take that offline and maybe catch me after the session, or happy to grab your contact information, see if we can find the answer for you.
Thanks.
What else interesting are you guys doing with graphs? Anyone else want to share? I know it's early, but I know you're thinking. Yes.
Hi, I'm Mark Novak. I actually spent 23 years at Microsoft, but that ended last year, so I'm at JP Morgan now. And we are using graphs to model all sorts of things. Threats, of course, but most recently we're trying to model cloud applications as graphs. And Kubernetes in particular, but also more traditional applications, auto-scaling groups in AWS, because we work across all cloud providers. And then the idea is once I actually understand what the application graph looks like, I can model data flow through it. I can model permissions required for various nodes. I can model control requirements around image scanning, endpoint scanning. I can actually form a understanding of how applications talk to each other, how they utilize various services. It's, there's actually a dearth of tools out there to do that, so we end up having to develop our own, not our core competency. But it's one of the most promising technologies we're working with right now.
Awesome. And I think there was someone behind you who had something to share as well.
Yeah, one project in particular that seems interesting for a protection approach with graphs is actually Cloud Mapper. I think that's, Scott Piper actually spoke at BlueHat about it, but it's similar to modeling like AWS or cloud services that you can detect policy violations and things like that. It seems like a very promising approach towards moving away from detection and response and more towards actually proactively finding those errors. Yeah.
Awesome. And behind you a bit further also?
Maybe I can talk loud enough. We use graphs to find administrator access inside environments. And wouldn't it be wonderful if Azure Security Center did that for us? Bloodhound does it better than the internal Microsoft tools at this point. But that's unbelievably useful for everybody. Not many customers really know where administrative access is and who has it, because it's always surprising.
Good, thanks for sharing. Any other ideas? Got one here in the front.
Yeah, hi. We use Graph APIs to consume Office 365 services.
Oh, good.
Specifically, one of the biggest uses is like log ingestion into our SOC. And we've been working through a few things like ensuring the logs get into the right state and at the right time, things like that. So we have provided that feedback to Microsoft quite a bit. So, but it's been a good use of just to integrate the Office 365 services into our on-prem infrastructure.
Great. Okay. Well, thanks everyone for sharing your ideas. I think that's a great start to the discussions today. Thank you for being here. And Ram, thanks for having me as well. All right. Thank you.